So our learning goal today states I can use, I'm over here. I can use tables and graphs to analyze functional relationships. In other words, you have to study them and see what's going on with them in everyday data. So we're going to just do one problem here where we're going to create a graph for this data that has been collected and from crash tests, and then we are going to describe what the functional relationship between the two of them is, okay? So let's take a look at, we have the speed of a car at the time of a crash, how fast they're going in miles per hour, and the other part of our relationship is the change in car length as the result of the crash in inches. So probably, would it get shorter or longer in a crash? Probably shorter, right? Okay, so which of those do you think would be the input and which would be the output? Or in other words, what depends on what in this situation? Would the speed of the car at the time of the crash depend on the change in car length? Or would the change in car length depend on the speed of the car at the time of the crash? Let's write it over here in the margin. Better come up with something for us to write though. The what depends on what? Does the speed of the car at the time of the crash depend on, is that the result of the number of inches in change length of the car? You know, how much the car length changes. Or is the change in car length the result of, does it depend on how fast the car is going, the speed of the car? Which one makes more sense? Sylvia? The second one, yeah. The change in the car length, the change in car length depends on, in other words, it is the result of, it is the output. Let's go over here in our table and put that. It is the output so the change in car length depends on, it is the result of, what again? What's our input? What's in charge here? What's in control? What's making things happen? Sam? Yeah, it depends on the speed of the car. So again, we have to make sure that we can understand how to compare the relationship. What is the input? What is the output? What depends on what? So the input causing the result is the speed of the car. So they already tell us, just like we already know, the speed of the car and the change in car length they are the parts of the functional relationship. Well then, when we have to graph these, when we have to create a graph of this data, that means one of those has to represent the x and one of them has to represent the y. So have we talked about which one is the x and which one is the y when we talked about input and output? Have we talked about that yet at all? Have we assigned either of them a variable? Okay. So the input is the x, and the output is the y in the relationship, okay? The input is the x in the relationship, and the output is the y. So that means when we go down here to our graph, we are going to label the x-axis as the speed of the car, okay? Because that's our input, that's our x value. Speed of car. But because speed can be measured in different ways, we have to show you and other people who look at your graph what's it measured in. So what's this measured in? The speed of the car? Miles per hour. So that's our input. Now let's go label and let's also put a little X here at the end of that axis, because the horizontal axis is always the X-axis. And the Y-axis is the vertical axis. So let's go up here and put a little Y at the top. And then I want you to put the change in car length on your Y-axis, because that's our output. So change. We don't want to put just car length, because then that would mean we'd have a car that's only 1 inch, and a 2-inch car. That doesn't make sense. So we say change in car length. You can turn your papers. Go ahead and turn your paper to make it easier to write. And what's that measured in? Inches. Okay, so in parentheses behind that, we're going to put IN for inches. Okay? Okay. Well, since these kind of nicely these go up by 1s and these go up by 20s, that means we could use a scale of 1s on the Y-axis, and we could use a scale of what on the X-axis? 20s. Every grid line would go up 20, go over 20. Okay, so let's go with, okay, can you see your grid lines better than I can? First one's going to be 20. The next one's going to be 40. The next one's going to be 60. And go all the way across. Every grid line getting numbered. I'm trying really hard to see mine. It should take you up to 140, I believe. Right? Is that what yours does? Okay. And now what are we going to go by on the Y-axis again? 1s. Okay. So we're going to start at 1 and keep going up. 2. And it appears it goes all the way up to 8. All right? Okay. Well, now we have our graph set up. We have the axes titled, showing what they're representing, and we have our grid lines labeled. We have our scales on there. We have it numbered across, our axes numbered. So now, how are we going to graph this? What will we do? What does a speed of 20 and a change in car length of 1, what does that mean as far as the graph? What point would that be on a graph? What ordered pair would we be able to write over here that we would be able to plot on the graph? What would it be? What comes first in the ordered pair? The X or the Y? The X does. So what should be first? The 20 should be first. And it should be followed by 1, because the Y value is 1. And then we have, what's the next one's ordered pair name? 42. So give all of those, we have 5 points that we're going to put on our graph. Give all of them their ordered pair name first. And then we'll go and put those 5 points on the coordinate plane on our graph at those locations. Okay, go ahead and graph those 5 points after you have their ordered pair names next to the table. Okay. Okay, what is the relationship in this now? That's the last thing we have to describe. What can we say? This is like what we did on those 2 in the homework for today when I said, off to the side of your graph, I want you to describe describe what's happening here. Okay, so what is it? Let's start with it. Either the speed of the car or the changing car lane, something. What's going on? Okay, well, I'll start it for you then you'll try and finish it for me. Speed of the car speed of the car at the time of the crash so look at those ordered pairs. The speed of the car, is that your x value or your y value? That's your x value, okay. So the speed of the car compared to the inches of the car lanes change, what happens? It goes from 20 to 1. So we have the speed of the car at the time of the crash. What would we have to do to that 1 to get that 20? Take it times 20, right? So the speed of the car at the time of the crash is 20 times the let's just say times instead of the, let's put 20 times the number of inches. 20 times number of inches the car shortened. That's what we decided it would do, right? Get shorter. That's their relationship. The speed of the car at the time of the crash is 20 times the number of inches the car shortened. Okay. Questions? Now, this is not actually what we would do in the input table, though, to the input to get the output, would we? Because if we took 20 times, so sometimes that's kind of confusing. If we took 20 times the input 20, would we get 1? No, what do we have to do instead? In the input table, we have to divide by 20, don't we? So it's 20 times the number of inches, but it's in the input table, what we're really doing to the input is dividing it by 20 to get the output. Okay, so don't confuse those things. Sometimes the description wouldn't be exactly what we would do in the input table. 20 times divided by 20, they're related though, aren't they? Okay, anybody got questions? Put that back up there if you weren't able to finish that. You can finish that now. If you are finished with it, you can go ahead and get out some loose leaf paper because you're going to need it for activity 4. Okay? Yes, Katie? Peace.